References for criteria and credits related to ladder and service companies are shown here. In looking at the formula for calculating credits for ladder and service companies, you can see that the existing company equipment totals are divided by the needed equipment totals, then that value is multiplied by the percentage of alarms receiving a ladder or service company response. The resulting factor is multiplied by the four possible points to give you the amount of actual credit earned. There have been some changes to the equipment required to be carried on ladder and service companies, so I encourage you to familiarize yourself with Appendix B of the Fire Suppression Rating Schedule. Before we can address the ladder and service companies themselves, we need to first talk about how many you have and where they are located. We will then discuss how many more might be needed and how we might determine where they should be housed. Before we go any further, I need to explain a couple of things. First of all, to make this discussion a little easier, I may occasionally use the term truck company. A truck company can be either a ladder or a service company. NFPA standards 1710 and 1720, which cover operations for both career and volunteer fire departments, do not specify that a truck company must deploy on structural fire alarms. Instead, they define the services that the fire department must provide to the public. To meet the service requirements using equipment required by NFPA 1901 for engine and truck companies, a truck company should respond to structural fire alarms. Truck companies may consist of a ladder or a service truck, and in cases where a dedicated truck company is needed but does not exist, the engine company in that station may be designated as an engine ladder or an engine service company. In any event, you need to understand that based on the data that we collect, what you might call a ladder truck, we might call a service truck, and vice versa. It all depends on what you actually need in the response zone where the truck is housed. When PIL does your grading, we first identify your existing truck response zones, then we determine whether or not those zones need ladder or service trucks. If the zone has more than 5 buildings that are 3-story, 32 foot to the eaves, or have needed fire flows above 3,500 GPM, a ladder company is required in that zone. If it does not, then a service company is required in that zone. When looking at the buildings in that zone, PIL does not double count. If a 3-story building has a needed fire flow of 4,000 GPM, it is only counted once. If no individual zone has enough buildings to need a ladder truck, but there are enough buildings in 2 or more zones, PIL will employ a building borrowing concept, and a ladder truck would then be needed in one of those zones if the total then exceeded 5 buildings. Okay, that explains how PIL looks at existing response zones. Now let's look at how we would determine if additional response zones might be needed. As I stated earlier, PIL will identify which fire stations house dedicated truck companies. First, we will calculate a standard response district by using our Geographical Information Systems ESRI database to add up the total number of road miles within 2.5 of all the existing truck company locations combined, and divide that total by the number of zones to give us an average number of road miles within the response zones. We call this number the Standard Response District, or SRD. The Fire Suppression Rating Schedule tells us that 50% of the SRD is the threshold for requiring additional response zones around stations that house a pumper but don't currently house a truck company. So we divide the SRD by 2 to determine that threshold number. Here's where it gets a little tricky. We then look at stations that do not house a ladder or service company, and using our GIS system, we determine how many additional road miles each of those stations would cover if there were a 2.5 road mile zone around those stations. If that number exceeds the threshold we set earlier, a response zone is needed around that station. If a truck is needed at a station and there's not already a vehicle in that station that we could call a truck company, we will designate the engine housed in that station as an engine ladder or engine service company based on the count of tall and high needed fire flow buildings in that zone. We repeat this process for all stations not housing a dedicated service company. Let's look at an example. In this example, the graded area has 4 fire stations. There are 6 three-story buildings in the graded area, and they are all within 2.5 road miles of Station 1. This area has a pumper in each station, and Station 1 houses a dedicated ladder company. Road miles within 2.5 of Stations 1, 2, 3, and 4 are 40, 50, 19, and 38 respectively. Since there is only one response zone and it's around Station 1, the standard response zone, or SRD, is 40, and the threshold for needing additional zones is 20 miles. You can see that both Stations 2 and 4 exceed this threshold with 50 and 38 road miles respectively. Therefore, a service truck is needed at each of these stations. After the grading is finalized, the graded area will receive a report from PIAL recommending that they put service companies at Stations 2 and 4. Let's assume for a minute that they do that, and when the graded area is graded again down the road, the data shown in the second deployment analysis is obtained. You can see that the SRD now represents the total road miles around Stations 1, 2, and 4, which is 128, divided by the 3 zones for an average of 42.67. PIAL rounds road miles to 1/10 of a mile, so for further calculations, this becomes 42.7. When we divide this by 2 and round the result, we get a new threshold of 21.4. Station 3 still does not need a service truck because its 19 miles does not exceed the new threshold. That might sound bad, but there's a possibility for relief. NFPA 1710 requires that the full complement of dispatched apparatus arrive within 8 minutes travel time plus 80 seconds for turnout on at least 90% of structural fire alarms. That's a total of 560 seconds. So what exactly is a full complement? Each fire department must decide for itself what that means, but for PIAL use, the full complement is defined as the arrival of the second pumper if needed by basic fire flow, and the ladder or service company. If only one pumper is needed by basic fire flow, the full complement is defined as the ladder or service truck. Capturing the full complement arrival time can be a little tricky. This time is the actual time that passes since receipt of the alarm, including the time it takes for the tones to sound until the time of arrival of the full complement apparatus. For alarms terminated within the 560 seconds, PIAL allows those alarms to be counted as meeting the NFPA 1710 standard. The most important thing to take away from this slide is that if the graded area meets the NFPA 1710 standard for arrival of the full complement with their existing engines and truck companies, then for insurance rating purposes, no additional truck companies are needed. This concludes my presentation related to credit for ladder and service companies. As always, we at the Property Insurance Association hope this information has been useful to you. If you should have questions about this presentation or any other rating-related topic, please do not hesitate to call. In closing, I'd like to thank you for your time and attention, and I hope you have a great day.